Explain delta type connection of current transformer. So in a delta type connection, the secondary winding of the CTs are connected in a closed loop triangle, and this connection is also possible with 3-phase only. The secondary winding of each CT is connected between 2 phases. You can visualize in both the figures that the CT is connected between R and Y phase, that is A and B, B and C, or A and C phase, like this. This connection is connected with this common point and it is connected with C phase, whereas this connection is connected with A phase. So this is how the CT is connected between 2 phases. Each side of the triangle represents one CT secondary winding connected between 2 phases, either between AB or BC or CA, like this. When the CTs are connected in delta manner, they measure the line currents indirectly. This connection is used to measure the difference in current between 2 phases, that is the current entering in I phase, A phase, and current in B phase. So it is a difference between IA minus IB, like this, or IA minus IC, like this. So in both the case, it can measure the difference between the 2 healthy phases, which is useful in detecting imbalances or faults, means like earth faults in this case. It provides a vector sum of the currents, and the resulting output will show only a value if there is an imbalance between the phases, because in the normal balance condition there is no current flowing in neutral or the balance core terminal. You can visualize this from the earth terminal. This. You can visualize this, there is no current because it is a difference between 2 phase currents. It eliminates zero sequence components. It is ideal for the differential protection system, and there is no need for neutral connection at the CT secondaries because it is the delta loop connection. It provides the loop connection. So simply this is A phase, B phase and C phase. This CT of A phase is connected with A to B, like this. See? It is connected with B, and the end is A is connected with the C, like this. This B is connected with this, and from this to it is connected with C, and this end is connected with the B. So B to A, like this. So this forms the difference current IB minus IA, IC minus IB, IA minus IC. This is the phase sequence IA, IB and IC, 120-degree phase shift apart. So this is the 3-phase balance condition of the current, IA, IB and IC phase currents. This current line is IA minus IC. This IA is in forward direction, IC is in this direction. So the difference is IA minus IC here. IA is in this direction opposite to the IB, so it is IB minus IA. Here similarly, IC is in this direction, IB is in opposite direction, so it is IC minus IB. Similarly to the reverse connection of this, IA, IB and IC again. So you can visualize this. IA is in this upward direction and IB is this from outside direction. So it is IA minus of IB because IB is in opposite direction. So the current is resultant current is IA minus IB. Now IB is going in this direction and IC is in opposite direction. So the resultant current is IB minus IC. Similarly, IA is going outward and IC is going inside this. So IC minus IA. So the current is IC minus IA. This is how the CTs can measure the balance current between the 2 healthy phases. And if there is an imbalance, then this CT can detect this imbalance and given the signal to the relay that there is an imbalance in the connection.